Okay, good afternoon. So let's see the synthesis of reaction. We have seen already synthesis of amino sugars. In that we have discussed one method only. So now we are going to discuss second method. Okay, synthesis of amino sugars second method. Sugars second method. Actually, I have explained amino halo sugars and this one. Now I want to explain the amino sugar second method. Okay. Second method. So let's see the simple structure. So here this is the form. Here OH, 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 and here we are having OH, but CH2OH. Is it or not? This is CH2OH. So first we have to protect these hydroxyl groups and these two hydroxyl groups. Okay. When it reacts with acetone in the presence of copper sulfate. Okay. So here we are doing catalytic amount of H+O. Here we are adding catalytic amount of H2SO4. So what it will do? It will protect it. It will protect it as here O is there, here O is there. We are protecting this. Means it will remove this H and this H and this O minus H2O, and these two methyl groups are this one. Okay. So see here it is having C, which is this is methyl group and this methyl group. So this is nothing but this methyl and this is the methyl. Okay. So next we have to protect this one also. Okay. Like this. Here we have to exchange this OH only. Is it or not? Okay. OH. Okay. So next, if it is treated with TSCl, what will be happened? If it is treated with TSCl, means tosyl chloride. So what it will do? Tosyl chloride in pyridine chloride. This is chloride. Tosyl chloride. So this H is replaced with this Cl. Okay. So we have to, so HCl, we have to remove this H and Cl, and TS group is replaced with this H group. Okay, is it okay? So next what it will do? So we have this group. If it is treated with NaN3, means sodium azide. If it is treated with sodium Na plus and N3 minus sodium azide. Okay, so what it will do? It will eliminate minus NaOTS, means we have to replace this OTS group with this N3 minus. N3 minus. So next step is here there is no change, only we are replacing this with N3. Is it or not? So OTS we are means we have to eliminate this Na OTS, and in this so N3 minus will attack this one. Okay, carbocation. So okay. క్లియర్ గా కనిపించట్లేదా అమ్మాయి? దీస్ ఆర్ ద బిగ్ రియాక్షన్స్ కదా. ఎందుకు? వాట్ ఈస్ ద ప్రాబ్లం? కనిపిస్తుందా ఇప్పుడు? ఓకే, అది సిగ్నల్ ప్రాబ్లం ఉంటుందమ్మా, అందుకే ఒక్కొక్కసారి కనిపించదు. ఓకేనా? కనిపిస్తుంది, ఒక్కొక్కసారి సిగ్నల్ ప్రాబ్లం ఉంటుంది, అందుకే కనిపించదు. ఓకే ఓకే. నాకైనా సిగ్నల్ ప్రాబ్లం ఉంటుంది, లేదంటే మీకైనా సిగ్నల్ ప్రాబ్లం ఉంటుంది. అది ప్రాబ్లం, ఒక్కొక్కసారి అది కనిపించదు. సో నెక్స్ట్, if it is treated with, means we have to do the reduction. N3 is there now, so we have to do the reduction. If it is treated with reducing agents like H2 platinum, H2 platinum, H2 platinum. So what it will do? Actually, N3 becomes NH2. Okay, it eliminates N2. Okay, it eliminates N2 molecule, and remaining, so for nitrogen it adds 2 hydrogen molecule, which is converted into NH2. Okay, which is converted into NH2. In the presence of H2 platinum, okay, in the presence of H2 platinum, this N3 becomes to NH2. Okay. Next, we have to exchange, means we have to deprotect these groups. Okay, by treating with MeOH in the presence of H plus. What it will do? It will give, so it will remove this. So methyl groups, means here we are acetyl groups are removing, and will get back the OH again. Okay, we'll get back the OH. Here NH2 group is there. Okay, we can write it as so here we are replacing this NH2 group. Here we are replacing this NH2 group. NH2 group. And here OH. Here OH. OH. Okay. So this is the second method of synthesis of combined sugars. I have explained already first method. Okay. Come on. So next, actually I have explained hollow sugars already. First and second method, I think so. అయిపోయిందమ్మా సెకండ్ మెథడ్ కూడా. హాలో షుగర్స్ ఒకసారి చూసి చెప్పండి నాకు. హాలో షుగర్స్ అయిపోయింది, ఒకసారి చూడండి. సెకండ్ మెథడ్, actually I have explained both methods, I think so. For hollow sugars, హాలో షుగర్స్ కి రెండు మెథడ్స్ అయిపోయినాయా లేదా చెప్పండి. Last class I have explained aloe sugars two methods. So next thio sugars. Next thio sugars. Synthesis of thio sugars. So this is the synthesis of amino sugars second method. Okay. So next one. Next one, synthesis of thio sugars. Synthesis of thio sugars. Okay. In carbohydrates, one or more hydroxyl groups are replaced by sulfur is called thio sugars. Let's see the method. Okay. And this is our sugar. Here what we have to do? Here it is having what it is having lone pair. Okay. So if you shift this bond pair of electron, so at that time what will be happen? This oxygen lone pair give the bond formation for this one. Okay. So what it will do? Here it is having becomes minus. Here CH2OH group is there. So here there is no bond between this O and this carbon. Just we are shifting this bond pair of electrons towards the oxygen. That's why the oxygen gets the negative charge. Okay. Here this bond pair of electron will give the so participate in the formation of double bond OH. Here oxygen is having trivalent. So actually it is a divalent, but it gives the lone pair of electrons for the formation of double bond. So that's why it acquires the positive charge. Okay, it acquires the positive charge. Next, what it will leave there? So this hydrogen will leave the electron pairs to nullify this positive charge, and this is transferred as a H plus ion, and it becomes the OH. Okay, here OH is there. OH. Okay. So next what will be happen here? This becomes OH here. H2OH. Okay. So next here double bond O. Okay. Double bond O with this OH group here. OH group here. OH group. Okay, ma. So next, if it is treated with nucleophile, okay, nucleophile. If it is at the nucleophile, that is nothing but pH SH. Okay, SH. So for this, what we have to do? It will attack this one. Okay. So at that time, here OH is there. Next, here it becomes O minus, and we are adding S here. Okay. One side H is there, and another side pH is there. Okay. So next here OH group is there. OH, OH. Here CH2OH. CH2OH. Okay. So next step is we have to add this hydrogen. It becomes a S plus now, so that's why it gives the electron pair to this one, and this H will go and attack O minus, and it is becomes a OH. Okay. So next, so here we can write it as like this. Here OH is there. Okay. So next here OH is there. Otherwise, okay, we can write it as this. OH. Here OH. OH. Next, in next step, we have to eliminate OH minus. OH minus. Okay. At that time, this sulfur is having lone pairs. One of the lone pair will donate the donate the electrons for formation of double bond, because so this OH will take the bond pair of electrons. At that time, this carbon becomes a deficient. So at that time, this sulfur will give the bond pair, this lone pair of electrons for this carbocation, for nullifying this carbocation. Then what will be happen here? OH is there. Next, here yes, double bond S pH is there. Okay, because it gives its lone pair of electrons. Is it or not? So next here OH, 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 OH. Okay. So next, what will be happen here, ma? So for this, here double bond S is there. We have to shift the bond pair of electrons. At that time, this oxygen lone pair will attack this carbocation and ring closing takes place. Okay, ring closing takes place. Here O is there, H is there. Next, here bond, here ring closing takes place. Another side we are having less pH. Okay, yes pH, and it is having plus charge because oxygen donates the lone pair. Okay, here OH, here OH, here OH. Next, so it is, we have to eliminate this H plus. It will give the bond pair of electrons to nullify this positive charge. Okay, and we have to eliminate the minus H plus ion. Then finally we got this product, thio sugar. Here O is there, here yes pH, OH here, OH, OH, here OH. This is the thio sugar. Okay, thio sugar. Okay, ma? This is the thio sugar. Preparation of oxidants. ఎక్కడ ఉంది ప్రిపరేషన్ ఆఫ్ ఆక్సిడెంట్స్ ఏంటమ్మా ఆక్సిడెంట్స్ నో జస్ట్ ఎగ్జాంపుల్స్ ఒకటి కొన్ని చెప్తామంటే అన్ని ఏం అవసరం లేదు అర్థమైందా ఓకే జస్ట్ అదే ఎగ్జాంపుల్స్ మాత్రమే నేను చెప్పాను ఎనఫ్ అన్ని ఏం చెప్పాల్సిన అవసరం లేదు ఓకేనా రైట్ నో ప్రాబ్లం అంటారు ఏం తీసుకుంటారు యూ కెన్ టేక్ ద what hydrogen you have to take the hydrogen okay so by taking the hydrogen and the carboxyl group so you can prepare the oxides so there is no need to write all the reactions just I have explained some examples okay na okay na Pravina అన్ని అవసరం లేదు కొన్ని రాయండి చాలు అక్కడికే అది చాలా బిగ్ టాపిక్ అవుతుంది మీకు అంత రాసేంత టైం కూడా ఉండదు ఎగ్జామ్ లో జస్ట్ నోట్ డౌన్ Next one, fructose. Okay. So we have already finished that glucose. Next, fructose. Okay. This fructose molecular formula is fructose of molecular formula C6H12O6. Okay, O6, and this is here. This having two primary alcohols, 3 secondary alcohols, and it is in keto form. What it is? It is in keto form. If you take aldehyde, it is present in aldehyde, means aldo form. Okay? Aldo form. Okay, ma'am? Okay, ma'am? So next. So here we have discussed about Fischer form. I have already explained what is Fischer form, because if you take up vertical lines and horizontal lines, if you write the formula in vertical lines and horizontal lines, then it is called as Fischer form. Okay. So let's see what is the Fischer form here. CH2 OH is there. So next here we will have C double bond O. Next C is there. Here CH2OH. Here CH2OH is there. Next OH, H, OH, H, OH, H. Okay. So this is the Fischer open chain form. Fischer open chain form. Fischer open chain form. Okay. So let's see this form means ring form. We have to write it as a ring form. Ring form of this one is OH here, CH2OH. Means we have to, if you shift this bond pair of electrons, so one of this one will get one. Okay. So next means this, we have to write this CH2OH. Okay, CH2OH and OH here. If you see here, if you shift this bond pair of electrons, so what it will be there? CO is there. Okay. Next, what it will do? We have to add this H for this one. Okay. For this one, and another side it makes the bond go to this C. Means here this is nothing but C. Carbonyl carbon. This is nothing but carbonyl carbon. At one end it is having CH2OH group. This is CH2OH group. Okay. And another side means this O becomes a OH. Is it or not? This O becomes a OH. Another, this contains like this. Okay. So next, another side means, so here if you shift this electron pair, and this carbon is having 3 valency. So for that 4 valency means fourth electron makes the bond with this fourth carbon, then it is called as pyranose ring. Okay, pyranose ring. If it forms the 6-member ring with this fourth, if you see here, actually 1, 2, 3, 4, fifth carbon. If it makes bond with this fifth OH group, then it forms the pyranose ring. Okay, pyranose ring. See here. Don't get confused. Here OH is there. H. Next OH group is there. Here H. Next here H is there. This forms the pyranose ring. Okay. This is a CH2OH. If you see here, 1, 2, 3, 4, 5. Fischer cyclic form. Okay. So this is the Fischer cyclic form. Okay. Fischer cyclic form. So this is the only alternate, because it is a in second position. So that's why it forms this one. Fischer cyclic. Furanose ring is only formed. Furanose ring, because this in aldehyde, if you take glucose is having aldehyde group at the first position. Is it or not? First position. So that's why it makes two rings, two possible rings which are 5-membered ring and as well as 6-membered ring. Okay, if it is forms, um, if it forms means in this one, so it forms means 6-membered ring, but it okay 6-membered ring. If it is forms 5-membered ring means with this carbon, it means here if first position no hydro means if it is having aldehyde group functional group at first position, so that's why it forms both membered rings means 5 membered ring and 6-membered ring. But it is not possible in fructose because functional group is at second position, so that's why only the form is so what is the ring form? Ring form here only ring form is a possible ring form is a uh, Furanose form, not the pyranose. It cannot form the 6-membered ring. Okay, it cannot form the 6-membered ring. It forms only the 5-membered ring. Okay, this is Fischer cyclic form. Fischer cyclic form. Fischer cyclic form. Just note down. Glucose లో two possible అవుతాయమ్మా ఎందుకంటే functional group at the first position. But here it is not possible. Only the possible ring structure is 5-membered ring only because it is present at the second position. Okay. We can write that Fischer cyclic form like this. Harvard. This is the Fischer cyclic forms. Let's see the Harvard form of this one. Okay. Because it is having two CH2OH groups because here if you see here this is one in CH2OH group and this is one CH2OH group. Okay, and we can write for this one. Okay, I will write here for this one. Harvard form of this one is CH2OH H here OH H H OH here CH2 OH H. So this form, this cyclic form we can write it as like this. Okay, like this. Alpha D fructofuranose. This is nothing but alpha D fructofuranose. This is Harvard form. This is called as Harvard form. This is the what it is? D gluco D fructo D plus fructofuranose. Alpha D. This one is called as alpha D plus fructofuranose. Okay. Here okay, I will write Can you difference? Can you difference this? So what is the difference between these two structures? Can you tell me? What is the difference between these two structures? చెప్పండి దీనికి దీనికి ఏం తేడా ఉంది? What is the difference? Just observe the functional groups above and upside and downside for this one and this one. Just tell me what is the difference between these two structures. Just tell me. దీనికి ఏంటమ్మా? What is the difference? These are having same structures. Same or different? ఇది సేమ్ ఉన్నాయా డిఫరెంట్ ఉన్నాయా? బాగా అబ్జర్వ్ చేయండి వీటిని రాసుకోండి ఒకసారి. Just note down and observe what is the difference between these two structures. Just tell me what is the difference. What is the difference between these two structures? Very simple. Different. Okay. So CH2OH group is downside. Here CH2OH group upside. Is it or not? Okay. Upside. If it is upside, this is called as alpha D. Alpha D. Okay. Alpha D here. This is not a plus. This is a minus. Okay. Minus fructofurulose. Fructofurulose. Here. What about this? The downside. So that's why it is called as beta D. Beta D, fructofurulose. Fructofurulose. Okay. So these structures we can write. This is the Hayward form. These are what are the forms? These forms are called as Hayward form. We have to write these two forms in cyclic forms. Okay. How can we have to represent in cyclic forms? Okay. Means conformations. How we have to represent the conformation form? Okay, if you see here, this is the cyclic form of, means conformational form of, cyclic form of this is cyclic form only, but conformations. What is the conformation of this alpha D fructofurulose? Okay, we can write this one. Alpha is nothing but down. Here it will be down. Okay, and what about here? If it is in upside, CH2OH, here H is there, OH, H, here, OH, H. This is called as beta D fructofurulose. Okay. So this is the beta D, beta, and this is alpha. Okay. Beta means here upside, downside means alpha. Okay, just wait the correction. Okay, this is beta D fructofurulose form. This is Hayward form. This is the conformation. Okay, chain conformation. Chain conformation of this beta D fructofurulose, and this is the chain conformation of the alpha D fructofurulose. Okay. Let's see the, okay. Let's see the, this is the what fructose. It is having same configuration as this one, okay. So we can determine this ring size by using the same methylation methods, okay. Is it clear now? Is it typo now? Next, sucrose, okay. Just structures are there, okay, and methylations are there. We can do this methylation if you treat it with this so dimethyl sulfate. So these hydroxyl groups are converted into methyl groups, okay. And on the, another, so if it is treated with HCl, so again it is give back this CH2OH, only this CH2OH, okay. It cannot give back all the OH groups, remains the same after reacting with HCl. First we have, if it is treated with dimethyl sulfate, all hydroxyl groups are converted into methyl oxy, means we have CH, this hydroxy H is replaced with this methoxy groups, so all are converted into Me. After reacting with HCl, this OH means retains back. Okay. So next, if it treated with this oxidizing agent, it will give the 4-member ring. So that's why it will give 5-member ring. It will give the 5 carbons at the end product. Next one, sucrose. 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 So sucrose, molecular formula is CC12H22. Molecular formula of this one is C12H22O11. This is a disaccharide. Disaccharide, not the monosaccharide. Glucose and fructose are monosaccharides because it contains only 1 unit of sugar. Okay, 1 unit of sugar, so that's why it is called as a monosaccharides. But this sucrose is a disaccharide, means 2 units of sugars are combined and form this disaccharide. Di means what? 2. Saccharide means sugars. Okay, so here this is a disaccharide because it combines and form the this one, okay. Sucrose and hydrolysis. So if it undergoes hydrolysis, it will give sucrose and fructose. It will give glucose and fructose. Glucose and fructose. Okay, means this is a combination of 2 sugars, so that's why it is called as disaccharides. Disaccharides. Okay, so here disaccharide sucrose in the form of, so this is a what is C12OH22 O11, okay, O11 on hydrolysis H2, means if it is treated with H2O water, so what it will be? It will give, so the plus glucose plus the minus fructose. D minus fructose. Okay? Fructose. What is the formula for this one? Glucose formula C6H12O6. Here C6H12O6. Here already O11 is there. Okay. So if you add two hydrogens and one oxygen, what it will it will give these two formulas. Okay. So let's see how it will form this one. Okay. Means here H is there and it forms a 5-member ring. Okay, this is a 5-member ring and this is said to be what it is called alpha D glucopyrrolose. Alpha D glucopyrrolose because it is a 6-member ring. If you see here 1, 2, 3, 4, 5 and oxygen 6. Okay, 6-member ring. Okay, plus we have to write the ring form of fructose. Ring form of fructose. Here H, OH. Okay. Next here OH, H. Here it forms this one H, CH2OH. This is the 4-member ring. 1, 2, 3, 4, 5-member ring. This is the beta D glucofructose. Here you can write it as a plus form. Here it is a minus form. Beta D minus fructofuranose. Fructofuranose, not the pyranose. This is the pyranose. If you see here 1, 2, 3, 4, 5, oxygen 6. If you see here 1, 2, 3, 4, 5. Okay. So this is a 5 means furanose. 6 means pyranose. Okay. Here, if it lost water molecule. So what it will form? Here, it lost this one. Okay. If you see here, here OH, I forgot this. Here OH is there now. So what it will be happen? It will remove OH and H. Okay, water molecule, and there is a bond found between this C and this oxygen. Oxygen is between this. If you see here, so it will be. You can write this as here O is there middle. Next here H. Here OH. Here H. OH. H. Next we are having this in this form. This is attached to this C. Okay. Next CH2OH is there. Next here C is there and OH. Here H. Here C. OH. H. C. This one H. CH2OH. Means this is the sucrose. What it is? Sucrose, Fischer projection form. This is a Fischer projection form of sucrose, projection form of sucrose. Okay ma. So ఎలా ఫామ్ అవుతుంది? It removes water molecule from this alpha D glucopyranose and beta D fructopyranose. So that's why, so this disaccharide forms. Okay, so there is a bond found between this carbon to carbon. There is a ether linkage is there. So that's why it is a disaccharide. Means both so glucopyranose and what is the fructopyranose rings are there. So that's why it is called as this one is a Fischer projection form of sucrose. How sucrose will form? So by dehydrolysis of glucose and fructose will give the sucrose. Okay. If you do the hydrolysis again, it will give back this glucose and fructose. Okay. Reversible reactions, and this is called as alpha 1D glucopyranosyl beta 2D fructopyranose. సో దీని నేమ్ నాకు ఇక్కడ ప్లేస్ లేదు కాబట్టి ఇక్కడ రాస్తాను. ఓకే. ముందు మీరు బయట తీసుకోండి. ఇంతే ఇవ్వండి. So this is called as alpha. This structure name is called as alpha plus, okay, alpha 1, because here at first position it forms the bond with this fructose. So that's why it is called as alpha 1D plus glucopyranosyl, okay, because this is the first one. Okay, 1 2 3 4 5. I have missed I think so one hydroxyl group. Just wait, I will check it out. Okay, here you have to write one more OH group. Just I have missed. Okay. Just I have missed. Just next one more carbon and hydroxyl. One more line. Okay. So glucopyranosyl, because this is said to be so this glucopyranosyl ring, alpha glucopyranosyl ring at first position. So that's why we have to represent the alpha 1D glucopyranose. Alpha 1, alpha. This is alpha. Okay. And what about this first position? Next, this is a D plus glucopyranosyl. Next, what is this? This is the beta. Beta at the second position. If you see here, this is the second. If you see here, this is 1 and this is 2. Because fructose in this fructose ring form is formed at the second position, which is a keto form. Keto is Keto group is in second position, so that's why. So you have to give the numbering for this one 1 and this is the for 2. So that's why this second carbon will make the bond from this one. So in this one it is the first one. In this fructose it is the second one. So that's why it is called as beta 2. Is here 1 here beta 2 B minus fructofuranoose. Furanose. You have to write all the names correctly. Okay, simple only, but this is the simple form. But don't forget, don't get confused. Okay, నేను క్లియర్గా చెప్తున్నానమ్మా మీకు. గ్లూకోజ్ లో ఏమవుతుంది, ఫంక్షనల్ గ్రూప్ ఫస్ట్ పొజిషన్ లో ఉంటుంది ఆల్డిహైడ్. ఓకే, సో దట్స్ వై ఇట్ ఫార్మ్స్ ద రింగ్ ఫార్మ్ ఫ్రమ్ ది ఫస్ట్ కార్బన్. ఇక్కడ రింగ్ ఫార్మ్ ఏమైతుంది, సెకండ్ కార్బన్ ఫార్మ్ అవుతుంది. ఈజ్ ఇట్ ఆర్ నాట్? Okay, second carbon makes the ring. Okay, so form the ring second carbon because keto group is at the second position in fructose. So that's why it is called as alpha 1D glucopyranose and beta 2D fructofuranoose. Okay, is it okay? So like this it forms the structure. This is the sucrose structure. Sucrose structure. Okay, this is the Fischer projection form of the sucrose structure. What it is called, alpha 1D glucopyranose beta 2D fructofuranoose. This name is same in all forms. Okay, this name is same in all forms. Name ఎప్పుడు చేంజ్ అవ్వదు, నేమ్ ఒకటే ఉంటుంది. స్ట్రక్చర్స్ మనం ఫార్మ్స్ మాత్రమే చేంజ్ చేస్తాము. ఓకే, సో దిస్ ఈస్ ద Fischer projection form and I will explain the Haworth form. Okay, Haworth form and conformational form. Okay, is it completed? అర్థమైందా ఏంటనేది? సింపుల్. మీకు ఇంకా క్లియర్ గా చెప్పినా ఇంకొకసారి మీరు చూడండి వీడియో, అప్పుడు మీకు అర్థమవుతుంది. ఓకేనా? So this is the Fischer projection form. Let's see the Haworth form of this sucrose. Okay, Haworth form is simple. One, we have to take up this glucopyranose. Okay, this is the what it is, alpha D plus form glucopyranose because it is a 6-member ring. What it is, beta D minus fructofuranoose because it is a 5-member ring. It is a 6-member ring. Okay, so after elimination of water molecule, minus H2O. Okay, so it eliminates OH here and H here. So carefully see this one. This is a 6-member ring. Here, okay, H is there. Here, O is there. Remaining groups will be same. Only the difference, we are eliminating water molecule from this one and from this one. Okay. Remaining will be same. Here H, OH, OH, H, H, OH. So here, what it will there? So we have to write O is there, and here what it is there? H is there. Okay? H, not H, CH2OH. Here CH2OH group is there. Here OH, H, H, OH. Here CH2OH, H. Okay? Means మీరు కంపేర్ చేసుకోండమ్మా ఏది ఫిషర్ ప్రొజెక్షన్ ఫామ్ తో ఇది కంపేర్ చేసుకోండి ఫిషర్ ప్రొజెక్షన్ ఫామ్ ఏమైంది దేర్ ఇస్ ఎ ఈథర్ లింకేజ్ వన్ దిస్ ఫస్ట్ పొజిషన్ టు దిస్ సెకండ్ పొజిషన్ ఓకే సెకండ్ పొజిషన్ సో దట్స్ వై ఇట్ ఈస్ అ 1,2 linkage. This is called as this is the first carbon and this is the second carbon because it is the first one now. So here second carbon. So that's why it is called as what it is called. This linkage is called as 1,2 alpha linkage. 1,2 alpha linkage because this is attached in alpha position. So that's why 1,2 alpha linkage. This is called as 1,2 alpha linkage. Next, let's see the conformational form for this one. Okay. For this, I will write here conformational form. So this is the separate one. So conformational form. Because it will be easy now if I write here. So that's why I am writing here. Conformational form means we have to write it as go here. Is it or not? This is go. Okay. See here OH group is there. Here OH. Here OH. Here OH. Okay. Next we are having H here. O is there. Next this is a we can write it as this one CH2 OH. Okay, here OH, here OH, here OH. This is the this form Pyranose ring which is linked to this as this is the conformational form of this sucrose. Okay, this is the Haworth form. Okay, I will write here. This is the Haworth form, and this is the conformational form. That's it. Okay, this is the Haworth form, and this is the conformational form of this one. Next, we have to do the methylation. If we do the methylation, sucrose will be over. Next time in next class, I will explain about lactose and maltose. I want to syllabus at least minimum. I want to finish this molecules by tomorrow's class. The next 2-3 classes it will take. 3 classes I think so for completion of this chapter. I will take 1.5 hours to 2 hours each day. Class will be, each paper is having 2 hours class maybe. Okay, 1.5 hours to 2 hours, because I want to complete this syllabus as soon as possible, if it is possible. Okay. So this is about the forms. Let's see the methylation of sucrose. Methylation of sucrose. Methylation of sucrose. Okay. We have to write the Fischer form. Here OH, H, here. So this is not OH because it forms a this one. We can write this as here OH, H, OH here, H here, next OH, H. This will form this one H, here CH2, OH. Is it or not? Here H is there, and here again it is having H. Next here C, CH2, OH. H, OH, here, OH, H, again it is having, this is a furanose ring, this is not having pyranose ring. Okay, if it is treated with dimethyl sulfate, what it will do? Simply, all hydroxyl groups are with. So it will be like this only. Go here, H is there. Here, this becomes OCH3H. Okay, so here H, this becomes OCH3. Next, all hydroxyl becomes a OCH3 groups. H, here we are having this oxygen. Okay, next it is having C, here CH2, OCH3. Okay, next C, H, it is converted into OCH3. Next here OCH3, H, here C, O group is there, H, CH2, OCH3. Okay, so means all hydroxyl groups are replaced with this methyl groups. We have to not here so many means not only this. If it is treated with dimethyl sulfate, it adds OCH3 groups. Okay, OCH3 groups. This is called as octamethyl sucrose. Octamethyl sucrose means here 1, 2, 3, 4, 5, 6, 7, 8. 8 methoxy groups are there, 8 methyl, so that's why it is called as octamethyl sucrose. Octamethyl sucrose. Okay. So if it is treated with HCl and hydrolysis, this ring will break. Okay, this linkage will be break. This 1-2 linkage will be break down. So that's why it gives the separate forms. It gives the separate forms, which is a here COH is a form. means only this CH3 is converted into OH. Remaining groups will be same. There is no change of this OMe groups. Okay, H groups is there. Next, OMe, then H, here, H, OMe, here, O is there. Next, CH2, OMe. On hydrolysis, it will give like this. It will give two parts again. Here, CH2, OH. Next, this is octamethyl group. OMe, here, H, OMe, here O is there, H, CH2, OMe. Okay, it will give back alpha D glucopyranose and beta D fructofuranose. Okay, so this is the methylation of this one. Okay, this is the methylation of sucrose. It will give the, so I have no space here, so that's why I am writing. This is the, you can write alpha D glucopyranose, methoxypharma glucopyranose. This is the beta D fructofuranose. Fructofuranose. Okay, fructofuranose. This is this one. Okay, in next class I will start the lactose structure. Lactose and maltose cellobiose structures are there. So I want to complete in next class. Okay. So because if I start now, it will take at least minimum half an hour. Okay. Even half an hour to not half an hour to 1 hour. Okay, now. So I will continue in next class. Okay. Thank you to all. So just take screenshot and note down this. Okay. Otherwise, once again, listen this class. Okay, now. Maybe tomorrow you have class at this 8 only, no? So I want to take tomorrow morning only. Okay. So be ready for tomorrow's class morning only. Okay. If you miss, you can listen after completion of class also. So no problem at all. Okay.